When it comes to predicting sales, we marketeers rely on our boss's fancy, sometimes astrology, and mostly guesswork. So today in this video, I'll be showing you SARIMAX model to predicting sales. So let's begin.
So first up, we'll be importing pandas as PD. And importing numpy as np. Okay, so there is already like a file which is there in my desktop that I'll be importing here. It's under users admin desktop and it's called sales.csv, and here there are dates. It's a time series data, so there are dates that I would want to pass. So this is true, and there is index column that is going to be date. So now we have the data frame, which is df, and the sales file is loaded in df. Now if I were to see this is having sales data, and it's a floating variable, which is like it's a real number in terms of sales. Now lib.pyplot, I'll be importing matplotlib as plt, and just a quick visualization on the data. If you see this sales data plt.show, this is how the data looks. There is right off the bat we can see that there is seasonal component to this data, so there are peaks and lows that repeat itself, so it's a cyclic data. So first we will be checking whether this data is stationary or not. For that we'll be using adfuller method. So from stats models.tsa.statTools import adfuller method. Now it's simple. What you do is you pass your data frame into the fuller method. Here you can see that the p-value is more than 0.05, which is our significance level. So this means that data is non-stationary, because if I'll just write it down for you, if p-value is more than 0.05, then we reject the null hypothesis that the data is non-stationary, which essentially means data is stationary. So to make it stationary, we'll difference the data. So for that I will call it a new data frame, which is called df_diff. Differential essentially means that we'll be shifting the data by 1 unit and then deducting that from the base table. So if you have some data for 1962 for the first month and the second month data we will reduce the first month's value from the second month's data, and then we'll do that for all the periods. Now there's definitely going to be one null value which will be there, so we'll be dropping NA out of this. Now if I check it again, adfuller on df difference, this is less than 0.05, so data is stationary now. So if we were to do that for using some different method, we could also take the square root of the data, or do some other computation like taking the log of the data to be able to make it stationary. But for the timing, this would suffice. So next up we'll be plotting our partial correlation and autocorrelation of the data. So from stats models dot graphics dot CSA plots, we'll be importing plot ACF, sorry for that, and plot PACF. So what we do here is we pass on our differential data and put the lags to 100 and put this to false. So if you see this on the autocorrelation function, it is clearly evident that these spikes that you see are after 12 are after 12 24 36 these kind of periods. So this gives us a cycle of the data. So earlier we saw that this data is seasonal, but now we know that the cycle for the season is 12 periods, which is 12 months. So after every 12 months the data is cyclical. Now to find out which model we'll be using, I have a shortcut that we could use which will tell us whether we should use ARIMA model or AR model or MA model, and also will tell us the order for the SARIMAX. So this time what we'll be doing is for that we have pip install pmd ARIMA. You install this. Now post that you import pmd ARIMA as pm results. I would call it results, and this pm dot auto ARIMA pass in. So now I'm passing in the base data frame, not the differential, not the difference data frame. Keep that in mind. I am passing seasonal is equal to true because this is going to be a seasonal data. Post that I will be passing the periods in the cycle as 12, which is m. The number of times we put difference the data under normal ARIMA and under seasonal data, both are 1. Information criteria is equal to true. Sorry, information criteria is AIC or BIC. I would be choosing BIC. So we would also want to trace all the results. So I would mark this as true. Pause. Plane is going, so I'm just pausing it. And I'll be setting my error action in case there is an error. What we do is we ignore that. Sorry for that. Ignore it. And fits. Let's keep it 100. And one more thing. So I'll be using stepwise is equal to true. So this will use some algorithm of its own to understand and reduce the number of iterations that this does on the data. So it will take some time to form different models. And total fit time almost 8 seconds, and the best model is SARIMAX, or you could call it ARIMA at 001 for the normal order for ARIMA and 011 for the SARIMAX with a cycle length of 12. Now what we do is this is going to be now very simple. Results.summary, you could summarize the entire results, SARIMAX, as I told you. Okay, and this is the AIC and the BIC levels for this. So if you can see, for all the models that it tried, this is the lowest BIC it could find. Now, for the almost the last steps, now we will be using results dot plot and diagnostics. This is just a quality check on the data. Now you can see the data on the is almost normal. This also shows the same, and so yeah. Now moving on, I would be from ARIMA.model selection. I'll be importing train test split. This is very common. Now I'll be calling it test and train, and on that model what I'll do is I'll train test split our base this thing data frame, and test size right now I'm keeping 30%. Now if you see our shape for test, sorry, this is without this, it's 51. So we have 51 data points in the test data frame. Not a data frame, but I would say it's a part of the data frame DF. Now what I'll do is I'll make some predictions to see how well this is performing on the test set. So I'll be using pd.dataframe and results dot predict. Sorry, yeah, and I'll be predicting it for 51 periods right now, just so that it matches the test sample. And for the index, I'll use the index as on the test size, prediction columns. The columns that I'll be using are will be called predicted sales, and last up I'll be adding a column to our test data frame, which is going to be predicted sales is equal to prediction. Now if I see, we have on the test data frame we have predicted sales and the sales. Last up we'll be plotting this to understand how this is performing on the test set. So for that, figures fix size, we can keep it like pretty big right now, and we will be plotting our train label training plt dot plot. I'll be using my test sample here. I'll be labeling it testing, and last up we have prediction, and I'll be calling it, you guessed it right, prediction. Okay, so legend okay. So now you see, this is our prediction and this is the actual set. I agree there is some difference in this, and it is because of the fact that last step, if you see, this is not following the trend, the actuals are not following the trend. If you base the entire model on this part of the data, it would automatically assume that this will go up. But if you see, it is closely following the patterns as on the actual data. So we'll have to we can test around with different test sites to be able to understand if this can be better. But for now, what we'll be doing is we'll be plotting, um, we'll be predicting the data frame. So right now we have 168 in our base data frame, 168 pointers. So if you have some more data around this, I think that will improve the prediction as well. But for now, I'll be importing tseries.offset. So what I'm right now doing is that I'm creating more um, data or more dates on the base data frame uh, to be able to then fill in the predicted values in that. This is future dates, and I'll be calling it df.index. So calling the last value, I'll be adding date of set, and I'll be using months x for a for loop for x in range 0 to 23. Sorry, should be 24. 23 will be included. Okay. There is some error here. So here there's this problem. Okay. So now that we have the offset dates, what we now need to do is future dates. If I look at this, this is all the future dates. Now we need to convert that into a pandas data frame. So for that, data set df we could call it this. Now data frame future dates, and what we'll be doing is we'll be using all the dates, and for the columns we will be using df.columns, the same columns as in the base data frame. Now if I see date df tail, I have these. Okay, so now we have empty sales, but we have the dates. Now we need to fill in the predicted values of the sales in this one. So we will quickly just check what is the shape here. This is 23 and 1, and so last up, data date df forecast. I'll be calling it forecast, like a new column on this one, and there I'll be using results.predict, and periods is 23. I'll be using 23 because 23 values of time stamps are there, and dynamic is equal to true. Okay, so now future df, you could call it. What I'll be using is concatenate two things. df, our main data frame, which was df with the future dates, data df. Sorry, this is pd.concat start. So we are here, sorry for that, concating two different yeah, sorry, this is this. Now future df looks like this. Finally, we'll be plotting this. So yeah, so this is how the plot looks like, and if you closely see, this is closely resembling the pattern, and it looks like it's part of the same series. So there you go. Future DF has all your predicted values and all your basic sales values using SARIMAX.
Like what you've learned? Make sure to subscribe to my channel, share this video with your fellow marketeers, and visit my website at ankitbutler.com for more such growth hacks. Thank you for watching.